Good afternoon. These notes are for section 8.2, the reciprocal function family. Before you begin the notes for today, please complete the warm-up problems number 1 through 5. Pause the video and then come back and check your answers. Number 1, what type of variation is indicated by the table? Find the constant of variation and the equation of the function. If you check both the product and the division of these, here's what you find. You have an inverse variation relationship. The product of x and y in every single case is negative 40. So the equation is x times y equals negative 40, or y equals negative 40 over x. For the second question, you'll notice that the division is constant. Negative 2 divided by negative 1 is 2. 4 divided by 2 is 2. Checking every value, you get direct variation where the k value is 2. To write your equations for this, you'll have y over x equals 2, or solving that for y equals 2x. Number 2, z varies directly with x and inversely with the product of a and b. Write the variation equation. Z is 8, x is 4, a is 2, and b is 16. Find the constant of variation. Z varying directly with x and inversely with the product of an a and b, x has to be on the top of your fraction, and the a and b have to be on the bottom. So we have z equals kx over ab. Substituting in your known values and simplifying, you get k is 64. Number 3, y varies jointly with a and c. It's understood those are going to be direct variation and on top of the fraction. Inversely, product of x, y will go on the bottom. So y equals k times ac over xy. Number 4, the set of coordinates is from an inverse variation equation. Find the missing value. Inverse variation implies that the product of a coordinate is constant. 3 times negative 12 is negative 36. This also implies the second point will have a product of negative 36 as well. Solving for y in this case, if x is 18, you get y is negative 2. Number 5, the set of coordinates is from a direct variation equation. Find the missing value. Direct variation implies that in a single coordinate, the y value divided by the x value is constant. So in this case, 18 divided by negative 6 is negative 3. So we have y over x in all cases for this particular problem would be equal to negative 3. Replacing y with 30, we solve for x, and you'll get negative 10. Pause the video and grade your homework. I've put on Blackboard the link for the homework answers next to this video. If you have any questions, please ask the people in your group or wait until I come back and we can go over any questions you have during Patriot period. Pause the video and grade now. Notes for today. 8.2, the reciprocal function family. You may remember that yesterday we discussed the fact that in an inverse function, the product of the x and y values are constant. For this particular problem, you have a class party. The students will share the cost for the hall rental. Each student will also have to pay $8 for food. The cost of the hall rental is already graphed. What effect does the food cost have on the graph, and explain your reasoning. So if I look at this particular problem, the inverse variation, the product is held constant. In all physical points, you'll see that the product is going to be 240. Additionally, if we wanted to add $8 on, it would actually add $8 to the total for each person. It would shift this graph up 8 units. This particular graph is representative of what's called the reciprocal function family, or the inverse functions. Any function f of x in this family is written as a over x minus h plus k, where x minus h cannot equal 0 because it would be undefined at that particular value. You have transformations occurring with this function. If a were negative, the function would flip over. The h indicates a horizontal shift, and a k, a vertical shift. If a value is less than 1, you will get a shrink, and if it's greater than 1, you'll get a stretch. The parent function of the reciprocal or inverse function family is f of x equals 1 over x. If you enter this into your calculator, what you will see is a function that is split in half, and it's a curve in the first quadrant and in the third quadrant as well. You'll notice that there is a point at 1, 1 and negative 1, 1, and you have two curves that are both approaching the x and y axis for infinite values. You have a horizontal asymptote right here passing through y equals 0, because in this particular problem x is undefined at 0, which creates this vertical asymptote. The function is undefined on this line. We're going to do sample problems now. Number 1, enter into your calculator y equals 3 over x. If you go into the calculator and put in the table of values, you will see an error where you enter x equals 0, and that being undefined. Graphing these points from the table of values, you will see the split curve happening. And you have your x and y asymptotes as well. So for this problem, when I look at the x-intercepts, these particular functions never cross the x-axis, so there are none. They also never cross the y-axis. The asymptotes, x is undefined at 0, so x equals 0 is an asymptote. Additionally, because there is no 0 in this, you have no y value coordinating with it, so you also have a y asymptote at 0. Your domain is all real numbers except x equaling 0 is excluded, so x cannot equal 0, and your range is y cannot equal 0 as well. For this particular problem, the 3 stretches the parent function by a factor of 3. Number 2, please enter y equals negative 2 over x into your calculator. You'll notice in this particular function you're also going to get an error at 0 because this function is undefined where x is 0. The negative 2, the negative will flip the original parent function over. This time you'll have curves in the second and fourth quadrants. You'll still have x and y axis asymptotes where x equals 0 and y equals 0. If you plot your points and connect with a smooth curve, whoops. There we go. X-intercepts, there are none as it doesn't cross the x-axis. Additionally, there's no place where this crosses the y-axis. Same asymptotes as before. Undefined at x and y equals 0 means the asymptotes are at x equals 0 and y equals 0. Your domain and range don't change. They're also all real numbers excluding x equals 0 and y equals 0. Okay. Number 3. Please enter y equals 1 over x plus 3 in your calculator. Enter into your calculator very carefully. Here is what it should look like. The 1 over x needs to be parenthesized, and then you'll have the plus 3. When you go to enter this into your calculator, you'll get a table of values where you will have a single error in it at 0, because once again it is undefined at 0. And you will see a graph where the curve splits as well, but this time the asymptotes are going to shift. The parent function will be 1 over x. The 3 causes a vertical shift up. And here is what your graph looks like. You now have a vertical asymptote still at y equals 0, but now we have a horizontal asymptote at y equals 3. drawing in my points and my curves. There we go. Now this time the particular function does cross the x-axis. You can see that this lower left-hand corner does do that. In order to figure out where it's crossing the x-axis, do second calc zeros. You could also let y equal 0 to find this value if you'd like. Pause the video now and find the x-intercept by doing second calc 0. If you do this in your calculator, you get negative 1/3, comma 0. If I take the original equation and put a 0 in for y and solve, I would also get x equals negative 1/3. This does not cross the y-axis at all, so that is none. And the asymptotes, you can see just like the parent function, you have x equals 0, but you did have a vertical shift, so you have y equals 3 as a new asymptote that is horizontal. Your domain and range. The domain is just like the parent function, x not equal to 0, but this time the y values excluded are at 3, so y not equal to 3. Number 4, please enter y equals 1 over x plus 1 minus 2 into your calculator. Make sure you parenthesize the 1 over the x plus 1. I've done it here as a double set of parentheses. I believe you can go ahead and skip the outermost parentheses and just type in 1 over parenthesis x plus 1 and then put your minus 2. It should still give you the same results. Graphically, this is what you're going to see on your calculator, and table of values, you'll have a single error at x equals negative 1. Visually, what you're going to see is a shift occurring. Now in this particular problem, it looks very similar to vertex form. You have a negative 1 down here at the bottom, which is going to be a horizontal shift. I say negative 1 because it's the opposite sign of what you see. And I also see a vertical shift down of 2. So in this case, you can see that my curves are still going to look very similar to the parent function, but the horizontal and vertical asymptotes have both changed. Drawing in your smooth curve. You can determine your horizontal and vertical asymptotes from the original problem. You have x plus 1, giving you an asymptote at x equals negative 1, and then the negative 2 on the back gave you a vertical shift down of negative 2, so there's your asymptotes, negative 1 and negative 2. You can verify this because of the fact that negative 1 gives you an error on your calculator, so that is the excluded value. For your x-intercepts, you can go ahead and do second calc zeros, or you can set the equation equal to 0 and solve for x. You would add 2 to both sides, and you could solve a proportion if you choose. Pause the video and calculate your x-intercept. For this particular problem, you're going to get negative 1/2 as your x-intercept. This time you do have a y-intercept. You will notice that the upper right-hand curve crosses the y-axis. In order to figure out what that y-intercept is, take your original equation and put a 0 in for x. You'd have 1 over 0 plus 1 minus 2, which gives you a value of 0, negative 1. Your domain and your range will include everything except for the excluded values from the asymptotes. So your domain is all real numbers except for negative 1, and your range is all real numbers except for negative 2. Number 5, please enter 2 over the quantity x minus 4 plus 6 into your calculator. Once again, I've entered these with double parentheses. I think you can go ahead and just avoid using the outermost parentheses. It should give you the same graph. Once you do that, you will see a curve happening in a split form just like we've had before, but there is a shift of the horizontal and vertical asymptote. You do end up with an error at 4. Visually, here's what happens. You end up with a horizontal asymptote at y equals 6 and a vertical asymptote at x equals positive 4. So drawing in your smooth curves from your points. And you can see in this picture that this lower left-hand curve, it crosses the y-axis and the x-axis, so you are going to have values for those. Go ahead and calculate your intercept with second calc zeros. You can also put in a 0 in for y and solve for x. Pause the video and do that now. You'll get an answer of the x-intercept of 3 2/3, 0. For the y-intercept, put a 0 in for x and simplify. Pause the video and do that now. You'll get an answer of 0, 5.5. You can see the asymptotes. You're excluding x equals 4. You had a shift horizontally to the right, so x equals 4 is one of your asymptotes, and y equaling 6 is your other asymptote from the vertical shift. Your domain excludes those values. X cannot equal 4 and y cannot equal 6. Number 6, write an equation for the translation of y equals 3 over x that has the given asymptotes. You're given that x equals 2 and y equals 3. The generic form for the reciprocal or inverse function is y equals a over x minus h plus k. Plus 2 is going to be a shift horizontally, and it's going to be a shift that's the opposite sign of what you see, and the 3 is going to be your vertical shift. So replacing the h with the 2 and the k with 3, you'll get the equation y equals 3 over the quantity x minus 2 plus 3. Number 7, pause the video and try to do this problem on your own now. Write an equation for the translation of y equals negative 2 over x that has the given asymptotes of negative 6 and y equals negative 5. The generic form of the equation is y equals a over x minus h plus k. Replacing h with negative 6 and k with negative 5 gives you y equals negative 2 over the quantity x plus 6 minus 5. Your homework for this evening is going to be page 512, 8 through 12 all, and 18 through 28 all.